Okay, this is section 3.4 in Math Links 8 on Pythagorean relationship. So this chapter focuses on utilizing the Pythagorean theorem on side lengths that are not perfect squares, so sides that are approximate. So we're utilizing, in section 3.3, we learned how to estimate imperfect square roots, like the square root of 15 as being 3.8 or so. And in this chapter, we're using that same knowledge to be able to approximate side lengths that aren't perfect. So the first question says, Kira calculated the missing side length of the right triangle. So here's the right triangle, and here's what she did. She said that this square here, I'm going to move this out of here. She said this square here, the area of this square is equal to the area of this square plus this square. Is that correct? No, it's not correct. Kira's not doing it right. What she should have said is that, I better erase all of this here, is that the area of this square here plus the area of this square here, because that's a leg and a leg, those two areas together will equal the area of the square attached to the hypotenuse. So what she should have said is 5 squared plus y squared, those two areas together, so 25 and y squared, will equal the area of the square attached to the hypotenuse, which is 13 squared. Or 25 plus y squared is equal to 13 squared, or is equal to 169. Right? Or better yet, if I just took this and said, what if I subtracted 5 squared from both sides? So if I subtracted that from both sides, I'd have y squared is equal to 13 squared minus 5 squared. And actually, that's what she should have put instead. So the answer is she's wrong. What she should have said instead is y squared is equal to 13 squared, take away y squared. Or this area, take away this area, equals this area. Question number 3 says determine the side length of each hypotenuse. I'm going to do both of the two methods you learned. The first method you learned was to use drawing. The second method you used was a formula. So we're going to do the first one with drawing. I'm just going to put my squares. I'm not going to complete the squares. I'm just going to pretend they're there. And inside each of them, I'm going to put the areas. This is 256. This is 144. And this is a leg. And this is a leg. And this is a hypotenuse. So the area of the two squares attached to the legs, meaning 144 and 256, add up to be the area of the square attached to C, which would make this 400. So therefore, C is equal to the square root of 400, which is equal to exactly 20. In the second question, we're going to use our formula, which is a squared plus b squared equals c squared. A and b represent legs. So this is a leg and this is a leg. Now, it doesn't matter which a and b is. Usually, I always make this one the height of the triangle is usually the a for when I do it, but it doesn't matter. So I'm going to put 16 squared plus 30 squared equals r squared, or the area of the squares attached to the legs equal the area of the square attached to the hypotenuse. 16 squared is 256. Now, some people think that 30 squared is a hard one to do, but it's not. Just do 3 squared, which is 9, and double the number of zeros. So there's 1 zero, so I'm going to double it to make it 900. Equals r squared, 9 squared. 1156 equals r squared. And I'm going to square root both sides. And when I do so, wait for it. Square root of r squared is r, and the square root of 1156. Bring this over here. Second function square root is 34. So therefore, r is 34. Your next question 5 says, what's the area of the square attached to the leg of the right triangle? So the first thing I'm going to do is put the area of the squares that I know. So that's 36 here, because 6 squared would be 36. And since the area of a square, remember, area of a square is represented by the formula side squared. So if the side length is 8, then the area is 64. Next question, B says, what's the area of the square attached to the hypotenuse? Would be the sum of those, or a squared plus b squared, which is 100. And what is the length of the hypotenuse? This distance here would be one of two distances. You can either say square root of 100, or, because that's a perfect square, 10. Question 6 says determine the legs for each. So I'm going to use two methods again. First method, I'm going to use a drawing. So I'm going to slap some squares onto there. Those are imaginary squares. If the length of A is 7, then the area of this square would be 49. If the length of this is 25, then its area is going to be 625. And 49 plus what is 625? I'm actually going to use subtraction to figure that out. I'm going to take 625. I'm going to subtract 49. And it tells me that this square is 576. And if the area of that square is 576, I better bring this down a bit here. The area, oh no, how horrible. If the area of this square is 576, then B would be the square root of 576, or approximately, is it approximate or exact? I don't know, 576 sounds like a perfect square to me. It's 24. So therefore B is 24 centimeters long. Okay, the next one, we're going to use our formula. A squared plus B squared equals C squared. A, B, C. R squared plus 24 squared equals 26 squared. R squared equals 5, oh, sorry, not equals. No. R squared plus, no, we just did 24 squared, didn't we? 576 equals 26 squared. I need a calculator, I'm not that smart. Square button, 676. Now that we get to this, we're just treating it like a simple algebraic equation with an exponent and a constant. Get rid of the constant first by subtracting 576 from both sides. R squared will equal 100. Square root both sides to get R equals 10. Or the square root of 100. Question 8 says the side view of a ramp at a grocery store is in the shape of a right triangle. Determine the length of the ramp. This is the ramp right here. Okay. So if I put squares onto here, and a square onto here, and a square onto here, then this area in here, let's take a pretty purple color here, will be 5 times 5 is 25, double the number of zeros, 2,500. 4 times 4, or 2 times 2 is 4, double the number of zeros, 40,000. And the area of this square plus the area of this square equals the area of this square. So therefore, this square here would be 42,500. Now, obviously, we're not looking for the area of the square attached to the ramp, but rather the ramp length itself. So therefore, that ramp length is the square root of 42,500, or approximately 206.2 centimeters long. Approximately. Is that right? Right. Question number 9 says Tina wants to construct a path along the diagonal of her yard. What length will the path be? Express your answer to the nearest tenth. So if I was to simply take this yard and trace out in nice pink marker her yard and bring it down here, I have a right triangle whose legs are 6 and 12. And the diagonal, or the corner-to-corner part of her lawn, is really going to be the square root of the sums of those squares. So this is going to be 144. This is going to be 36. The area of this square attached to that diagonal line is going to be 180. So what is the exact measurement of the diagonal? The exact measurement is the square root of 180. That is the exact distance. Now that is an imperfect square, which means it's approximately equal to a number. Grab my calculator, ask it to do some thinking for me. It says it's approximately 13.4 meters long. So the length of the diagonal in her yard is the square root of 180. or approximately 13.4 meters long. Question 11. The right triangle below has a square attached to the hypotenuse. What is the perimeter of the triangle? Oh, this is a great question. Give your answer to the nearest tenth of a centimeter. So the first thing we're going to do is we're going to say, what is the area of this square? Okay. So we know the side length is 17. Obviously, if I square it, I get 289. So what we now know is in our triangle, we know one length for the perimeter, but we don't know the other two. How do I figure out this distance here? Square root of 914. So I take 914 and I square root it, and it gets me roughly 30.2. So to get the perimeter, how many sides do I know so far? I know 2 of my 3 sides for the perimeter. The one I don't know is this area or its side length. But how do I get it? Which one can I figure out? The first thing I can figure out is the area. And I'm going to get that by taking this, take away this, will be this, because this plus this is this. So, 914, take away 289 is 625. So this area is 625. And how do I get the side length? Square root 625. 25. So now when I redraw my triangle over here, do I know all 3 side lengths? Yes. And the perimeter will be 25 plus 17 plus 30.2, 20, 30, 60, 72.2 centimeters. The perimeter is 72.2. Question 12 says the hypotenuse of a triangle, or as some students say, the hypnosis of the triangle cuts the circle in half. What is the diameter of the circle? So there is the diameter poorly drawn. It's the hypotenuse of the right triangle. So over here, if I was just to redraw another right triangle, I put 7, 5, and X, and put my squares on here. This will be 49. This will be 25. And will this one be, which one is it? 49 take away 25 or 49 plus 25? Which one will this area be? 49 plus 25, which is 74. And therefore, if the area of that square is 74, then the side length is the square root of 74. That's not 74. Which makes it approximately 8.6. So, back to my circle. What's the length of the diameter? Roughly 8.6 centimeters. Now, a variation on your test might be, what is the circumference of the circle? Okay? So how do we get circumference? Circumference is equal to pi multiplied by diameter, or 3.14 multiplied by 8.6. So the circumference of this circle, I need a calculator. 3.14 multiplied by 8.6, roughly that. Or another alternative might be not what's the circumference, but what's the area. Area equals pi r squared. What's the radius of the circle? If the diameter is 8.6, what's the radius? 4.3. So 3.14 multiplied by 4.3 squared. 4.3 squared would be 4.3 multiplied by 4.3, 18.49. Multiply 18.49 by pi. The area is roughly 58 point something. I can't remember, so I'm too lazy to go back. Everyone get it? Variations you might see on your test. And your last question, determine the length of the base of the large triangle. This is the base here. And as we can see, this triangle here and this triangle here are identical because they both have 8, 10, and whatever this is. So they both would have x and x, right? So I'm going to take this black marker, trace the triangle, and bring that triangle over here. 8, 10, and x. So if I draw mine here, this would have an area of 100. This would have an area of 64. Now, is this 100 plus 64 or 100 take away 64? Right, because it's a leg, hypotenuse. So in order to get it, we would use subtraction. 100 take away 64 is 36. And therefore, x is 6. So if this distance is 6, what's this distance? So what's the total base distance? 12.